back to NCRT class 9th, chapter number 8, motion. Children, in the previous class, we came to know describing a motion and motion along a straight line. So, in today's class, we are moving with one more concept, that is uniform motion and non-uniform motion. This can be like a difference we can learn, children, so that it will be helpful to understand more clearly. First, we will discuss about uniform motion. What is this uniform? Uniform means what here? Not the school uniform which we are going to wear, children. In the physics, that is in motion, we are studying uniform means something called here periodical way, isn't it? Same, you can say that equal or periodical can be called as a uniform. Then what is the meaning of a uniform motion then? An object is said to be in a uniform motion if it travels equal distances in equal interval of time. Then it is said to be in a uniform motion. It means that, children, any object, if it covers equal distances in equal amount of time, then we call it as a uniform motion. Let me write its definition, children. That is, an object is said to be in uniform motion if it covers equal distances in equal intervals of time. Understanding, children? The meaning is what here? Equal distances in equal interval of time. For example, let us take an example to understand it better, children. A car is traveling. If we plot a graph, children, let us assume that a car is traveling, that is, let us take here on x-axis timings, children. On y-axis, let us take a kilometers, 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, like this. That is what? Distance. We can note it as a distance. Here what? This is what? Time interval on x-axis, and we have taken distances across y-axis. What is the definition of a uniform motion? It has to cover equal distances in equal interval of time. It means that initially at this position the car is at rest, so 0 mark. So at 1 minute of a time it covers 1 kilometer. So this is our point. Shall we note it down here? Okay, we'll mark here. At 1 minute of a time, let me write here, at 1 minute, what is its distance? 1 kilometer. For the next 1 more minute, means 2 minutes, 1 plus 1, 2, no? So for the next minute, it covers 2 kilometers. And similarly for the next, that is 2 plus 1, you have to equally add the timings here. Every time got increased by 1 minute. Here also the distance is also going to be equal. 3 kilometers. So at 2 minutes it has covered 2 kilometer. At 3 minutes it has covered 3 kilometers. So like this, after noting or marking the points, children, we need to join all these points. We are getting a straight line. See here, something called, at this much of a time the car is traveling this distance, isn't it? For the next, this time it covers this much of a distance, and similarly for this amount of a time it covers up to this much of a distance. Means there is an equal distance it is going to cover in equal interval of a time. This is called as a uniform motion. So is it clear, children? An uniform motion means it has to cover equal distances in equal interval of time. And one more thing you have to note it down, children, here. Always when we plot a distance time graph, this graph is called as a what, children? Distance time graph. In case of a uniform motion, we will get a straight line. What is this? This is a straight line from the origin, no? So you had to remember this point. This is a very, very important. Got it, children? So an object is said to be in a uniform motion if it covers or travels equal distances in equal intervals of a time, then it is called uniform motion. And when we plot a graph, we are going to get a straight line from the horizon, or in this way also you will get a what? Straight line. This is what? Uniform motion. Now let us discuss non-uniform motion. It's a very simple, children, opposite case. If an object covers unequal distances in equal intervals of a time, then it is called as a non-uniform motion. That is, an object is said to be non-uniform motion. Non-uniform motion if it covers or travels unequal distances in equal interval of time. Then it is said to be a what? Non-uniform motion. That is unequal distances in equal interval. See, children, the meaning here is very simple. It is covering unequal distances. Means sometimes it is covering normal and sometimes suddenly it got increases. This is the meaning of unequal. There is no equal distances. In the as we have seen in the uniform motion, it is covering equally, periodically. That is, if time increases, what happens to the distance? Distance also increased. But in case of a non-uniform motion, if one quantity increased, means the second may or may not increase. This is the meaning of unequal distances. Suppose if we plot a graph, children, let us consider this is 1, 2, 3, 4 like this, and this is 1, 2, 3, 4, 5 like that. So for 1 minute, here is what? This is what on x-axis, timings, no, children, and this is what? Distance. For 1 minute, the car may move up to here. Means it may cover 1 kilometer. And for the next minute, means for the 2 minute, it may cover 3. And for the third minute, it may cover 5th. So when you, that is here, third one is here. When you join all these points, children, you are going to get a curved line. Like this, you are getting a curved line. See here, for 1 minute, this much if it has traveled a distance, for the next minute, it has to travel up to here. But here, what is happening? 3 kilometer. Distance got more. Unequal distance it is going to cover in equal interval of a time. For the next third minute, it is covering 5 kilometers. Isn't it, children? Because of this reason, we are getting a what? A curved line in case of a non-uniform motion. That is what? The distance time graph is curved line in case of a non-uniform motion. It can also be called as a accelerated motion. This we will discuss later, children. Better you remember. What is the distance time graph in case of a non-uniform motion? Curved line. Whereas here it is a straight line. Is it clear? And you can take many examples, children. That is, in case of a non-uniform motion, a freely falling object, it is an example of a non-uniform motion, isn't it? And similarly, best example, children, that is train in the railway station. At the stationary position, it will be at a no motion. When it starts, means when it is ready to leave the station, the speed of the train will be slow, isn't it, children? So what happens when it reaches at the middle? Train is going up very fast at the middle, isn't it? Because there is no ground, no traffic, isn't it, children? And the path is what? Straight. So what happened? The speed got increased. And the same train, when it reaches the another station, the next station, if it reached, means what happens? Once again the speed get decreases. First slow, next fast, and the very next what happened? Again slow. So this is what unequal distances and in equal interval of time. So you can take a railway station, that is train moving in a railway station is an example of a non-uniform motion, and freely falling object also is a non-uniform motion. Is it clear, children? Okay. Uniform motion means always you have to keep it in mind. Equal distances an object is covering in equal amount of a time. Sorry. And the distance time graph, in such a case we are going to get a straight line. Whereas non-uniform motion, unequal distances is going to cover by an motion of an object in equal interval of a time. Got it? And the distance time graph in such a case is what? A curved line.